Hey, good morning, everybody, and welcome to today's webinar. What we've done is we've actually started a series that we're going to be doing throughout the year, kind of going through the process or some of the reasons for modernizing your wireless network. We really kind of developed this after a lot of questions, a lot of calls, a lot of meetings with customers, integrators about, as we go through this digital transformation, what steps need to be done in order to modernize their wireless network? So we kind of not only did this within a webinar series, but also in a whole format in a section within our website. So today, really what we're going to do is we're really kind of talking about what we're going to talk about. So there's kind of an overview of what to expect from the coming year. And then in each of the follow-up sessions, it's actually going to be diving into a specific topic that we get often, for different reasons why they need to modernize or why you need to modernize. And so we want to basically make this a very informative, but also kind of a tool that you can use as you're modernizing your network as things progress forward. So as we kind of take this going forward, to give you an idea of who we are, so Esteem was established back in 1982. So we exclusively design and implement wireless networks for over 38 years. And what that allows us is, because we're the manufacturer, is that we design everything specifically for kind of the rigors of industrial automation. But also what it allows it is that we control all of the IP. And this is both from the hardware as well as the software side. So really what this also does is it also keeps us compatibility committed. We don't want to leave anything behind. So when you're looking at upgrading these networks, we want something that's going to be in there for the long haul. It's something that we can grow with. We are all made here in the US. We're manufactured and headquartered out here in Washington State. And we really have probably the most complete portfolio within the industry. So we cover the licensed frequencies, which is your 150 to 174, 217 to 220, the 450 to 470 megahertz. Then we also get into the license-free frequencies. This is primarily what we're going to be talking about in this series, which is the 900 megahertz. We deal in the 2.4 gigahertz, and we deal into the 5.8 gigahertz. All of them have a place. All of them have a reason. There's kind of barriers. There's reasons why we'd want that, reasons why we may want to go into a different direction. To date, we've got a little over 45,000 modems in service worldwide. So kind of when we look at this, is the major markets that we really are involved with is your water, wastewater, your oil and gas, mining, material handling, power and energy, agriculture. We're getting much more into the infrastructure as well as this factory floor and AGV use. And this is really a big reason for a lot of this modernization. And we kind of look at this on a little bit bigger scale to this, is what we're really seeing now, and you probably heard the terminology, and there's a lot of different ways to look at this, is this digital transformation. You can kind of see in this little ladder on the graphic on the left, is that we're now sitting up here in Industry 4.0. And really what has happened is that we've really moved from a serial-based communication scheme, which was really designed to be device-level communications, device to device. It's kind of now moved into the Ethernet side of things, which really is a couple things. Number one, there's been a transformation of the way that data is constructed, as well as the physical connection to it, but it's really evolved not only to do that, but the big goal of this is no longer are we looking at device level communication. What we're looking at doing is networking, or a connected model of this. Everything is being brought into that greater network or connected enterprise. So we kind of look at that connected model. This really is a great little graphic to show exactly kind of how this all lays out. And over on the left, we've got the things. These are your devices. These are your PLCs. These are your cameras. This is your laptops. This is your thin client tablets. It's kind of the things out there in the field. And ultimately, we need to have some connectivity. This is that network of the gateway to get that data so that we can actually do something with it. So your analytics, basically your machine learning, visualization, automation. So really it's kind of this whole thing. We need these four pillars. We got to have the things, we got to be able to connect them to get the data so that we can analyze it and make basically useful information out of that so that we can act upon that. So we kind of look at that and say, okay, so for this connected model, what do we actually need to have out of this? What are the kind of those must-haves that we need for this? Well, it's got to be reliable. You know, we've got to have persistent data acquisition. It's got to be right there when you need it all the time. It's got to be secure. You know, it's edge-to-edge cybersecurity is huge. You just read the news, you look at some of the different things going on. Security is paramount to what's going on. You need to have both layer 2 and layer 3 connection types. Do we want a flat network? Do we want to have subnets? Do we want to have a routed network? It needs to be flexible enough to be able to handle both of those. Says we also want to have the ability to take that data and put it on site. We want to be able to put it into the cloud if you want to do that, or even both. So it needs to also be very scalable. It's got to be cost effective, and it's also got to be future proof. Kind of goes into that, what I was talking about before. We need to make this network so that we can, it can basically be scalable as the years go by. It's also, today, it's got to be frictionless between the IT and the OT. You know, it used to be something that was very separate. It's now really merged into one thing. When we start dealing with networking, it's got to be basically something that both the IT and the OT really kind of get along with. It's got to be interoperable, right? So we've got kind of this, you know, these must-haves of a connected network, and, you know, making that leap to get to these things when we start dealing with wireless is that a lot of times now we've got a wireless plant that needs to be modernized, right? And so this is really kind of what we're going to be doing here, is walking through what is that modernization, because there's a lot of different reasons for it. So when we start looking at modernization, really what we're kind of got to take in mind is it's really kind of a 3-step process. As we've got the what, and this is things like what kind of data is it? What's the application demands? Is it serial? Is it Ethernet? Is it something that's moving from serial to Ethernet? Do we need to increase the reliability through things like meshing and redundancy and self-healing? And we've got cybersecurity. That's a big one. You know, in a lot of these old wireless networks, there really was no encryption going on. We were just basically, your frequency was your only method of security. So that's a major thing. We've got to make this more secure. Is your application something that's going to have mobile roaming capabilities, like an AGV or vehicles that are going to be moving throughout an area? You know, do you have mobile workers or the thin clients to where we need industrial Wi-Fi so that they can be brought into the network? Does this need to be something that maybe isn't a permanent solution, but it's a rapid deployable network for, you know, setting something up kind of in the heat of the battle, you know, whether that's going to be something in the nature of a temporary location, or it could even be in a natural disaster. Those are kind of the application demands. So we've got to understand those first. Then we got to really kind of understand the physical environment that we're dealing with. And this is going to be things like distance. You know, now all of a sudden, if you're used to using a licensed system that had much greater range to it, well, if we need to be able to meet some of the applications, some of those distances are going to change. The terrain is going to have a huge impact. You know, when we get into these high frequencies, line of sight is major. So if we're dealing with trees, something that you may have been doing previously in a wireless network, say at a low frequency down at 150 megahertz, or now trying to get into a Wi-Fi network, things have changed. We need to take that into account. We're also dealing with physical environment, and this is kind of twofold. It's not only, you know, what kind of a conditions do we have to live in, you know, in the industrial world or outdoors, and some of those temperature ranges that we see within the industrial world, but also we look at the RF environment. When we start getting into these unlicensed frequencies, no longer do you have exclusive use of that frequency, we're into a shared frequency. So once we kind of balance both of those, what we're looking at is kind of then the how, you know, the frequency, the bandwidth, and that's going to point us to an appropriate technology. And it's basically a 3-step process we need to go through, and that's really what we're going to cover within this series. So as we kind of look at this, if you go onto our website, basically onto the main page there, there's really a couple ways that we can get to it. There's a big button down kind of at the bottom there that says Modernize Your Wireless Network. That's going to take you into this section that we've designed specifically for you. You can go down under Solutions, and right at the top it says Modernize Your Wireless Network. going to take you to the same place. If you want to just type it in, you can go to steam.com/modernize. That's going to get you to the same thing. And really what this is designed to do is to walk you through the process of modernizing your network. So what you're going to be first looking at is kind of like what we talked about, is the what of it. So we kind of broke this down into the major sections that we're approached with. Says this is the reasons why I need to modernize my network. And so you can see there that we've got Ethernet. It's done in for reliability's sake. I need to make it more secure. Mobile applications, Wi-Fi connectivity, or deployables. These are kind of the main reasons, the main nuggets of why people are doing it from an application standpoint. So as you kind of delve a little further into it, and these are also going to be the individual webinar sessions we're going to do throughout the year. We're going to tackle each of these specific topics and expand upon that and go into greater detail. So sure to tune in for the rest of these webinars so that you can go through this journey with us. Really, when we start looking at Ethernet, this is probably the #1 reason for wireless networks to be basically modernizing is the communications that they're using, such as a PLC. Now we're moving from a serial-based communications into Ethernet. And we want to bring that into a network. Well, that basically now everything has evolved into Ethernet-based communication. So the radio needs to be able to handle Ethernet, right? Pretty simple. This is going to be for your SCADA system. Also, where this gets used is for IP cameras. A lot of times now for security reasons, we want to get a camera out at a location so that we can keep an eye on, a remote site, whether that's, something for intrusion, something for, being robbed for the copper. There's a lot of different reasons why cameras are going in. And of course, IoT, it's kind of the huge thing is we have this connected and everything operates on an Ethernet network. So we're going to delve into that. And the next section that we're actually going to go through in another session is going to be dealing with the reliability. So really what this comes down to is what a lot of people just call mesh, right? And so what is mesh? Well, it's really a self-healing, redundant backup communication paths that switch automatically. So it's going to give us that self-healing capability and multiple pathways. It can be a canopy for overall Wi-Fi coverage that is going to happen within a geographic area. Really what we're trying to do is to assure data reliability between devices. We want to make sure that if something happens, can we fix it, go around it automatically without having to reconfigure the entire network. We basically use this as we get into it a little bit more. We'll kind of go through the details of how those routes are configured and prioritized by you. It's something that we want to give you full control over. At the end of the day, really, the self-healing and the mesh capabilities, it really comes down to reliability. Okay, the next one we're going to jump into is going to actually be cybersecurity. This thing is front and center for us today, especially when you start to look what's going on around the country, around the world, intrusions, some of the hacking, some of this going on, is that network has got to be secure. And that's not just a wireless network or just a wired network. It's got to be something that is basically multi-layered. And so that's really our approach to it, is that it's probably the most challenging issue faced for a lot of wireless networks today. And so we've actually implemented multi-layer security within the radios to be able to do that. So you can now use up to AES 256. We can allow or deny particular clients if you're in a Wi-Fi system. This is something that we can then tap into if you want to use radius servers. We can actually utilize radius servers instead of just strictly passwords. There's a whole host of information that goes into the cybersecurity and a lot to consider. And we're going to touch on that in another session. And so that's kind of what really where we jump into on that. When we start talking next about the mobile applications, really what this is don't think of this as like a cell phone type of mobile application. Really what we're dealing with is mobility, is digital factory floor transformation. We're dealing with things like AGVs or maintenance vehicles that need to be able to roam throughout an area. Okay, this requires basically not only that roaming capability, but the speed to be able to support that. These are rarely fixed locations, So we need to be able to basically support that mobility and what goes into that on a network. And so we want to look at that. Why do we want to modernize for the mobility, and how do we best do that? And so again, these are across the board for 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz. Really kind of all over the place. Wi-Fi connectivity is another big one. This kind of goes not only hand in hand with the mobility side, and the AGV use in vehicles, but now all of a sudden we're dealing with the mobile workforce. Whether that's out at an oil field or it's factory floor automation, we're dealing with being able to bring in that mobile worker into the network without having to physically tether into it. So you're going to use a Wi-Fi solution. So if you're using thin clients, how do we add to that the ability to make this a better network, a more efficient network for you, so we can actually do high-powered Wi-Fi industrial grade within this meshing. And so basically our 2.4 gigahertz and the 5.8 gigahertz can support this whole 802.11 or the Wi-Fi, type 4 networks. And so what we want to be able to do is also be able to utilize that Wi-Fi maybe for remote assets. These can be sensors that are Wi-Fi capable. Now they can be brought in directly into that network. That's another big reason for this modernization push, is I'm trying to do more, so how do I do it? And this is really kind of what this session is designed around. Then we get into the deployables. This is kind of a new set or area for where we're going after, and we've actually created this a whole rapid deployable network. So this is going to be used for areas such as temporary mission critical communications. We've got disaster recovery centers, emergency shelters, be natural disasters where we need mesh for field communications, in which we need to have Wi-Fi calling or just communication, so that the field work, those frontline workers, whether they're dealing with fire or the hurricanes or anything like that, they've got to be able to communicate to do that. So the demand for something that can be easily and quickly rolled out really is pushing, a lot of this modernization. We can do a lot more. So how do we implement that? So kind of the next part, those are the what of modernization. Then we're going to look at kind of the where. So when we start dealing with the where, first one up really to discuss really is going to be the distance, right? So what we're looking at is how far between these locations do we need to go? As we're modernizing, the newer systems require more signal to get that data rate. So if you're accustomed to getting, say, 15 miles onto a link because you're using a 150 megahertz license frequency, well, when we start moving into those 900 to 5.8 gigahertz, frequencies, so that range is going to shorten up because it's unlicensed, so that there's a cap on how much power can be emitted. So how do we calculate that? We're going to walk through that, and say, okay, how much distance can I get? What kind of range can I have? And we got to talk about the terrain, right? Where are we going with this? When we start looking into this, we've got trees, we've got mountains, we've got hills, we've got buildings, all these things that come into terrain that were very easy to overcome with those low frequencies in the licensed ranges. Again, now we're dealing with much more line of sight dependent frequencies. So how do we basically utilize the technology? Because now one of the other benefits of that meshing technology is anybody can act as a repeater for anybody else. So just because we can't get there in a straight shot, sometimes we got to go around it. We may need to bounce through the city. We may need to go up over the water tank down into a lift station. So the actual terrain has a great impact on modernization, and we're going to jump into that, both feet and really kind of get into the nuts and bolts of that. And we've got really the environment that we need to look at, and that's really kind of twofold. When we're looking at the environment, like I mentioned, is that we're dealing with something that we build the radio so they can be mounted directly outdoors into the elements, so that we can eliminate those costly feed lines. Also, where a lot of that power is robbed through attenuation going up that cable. But also we're dealing with, like I mentioned, is when we get into these unlicensed frequencies, now we're also having to deal with other users in the area, and how much signal do I need, and how do I determine which one to do that? So these are all kind of things that we've got to take into account when we're going down this modernization world, and different reasons. Again, what we wanted to do here is to create a space to where you could be addressing what your needs are specifically within that modernization journey. So that kind of takes us to the how, right? And so there's really different steps to this. It's something that you may just need some help. You want to kind of walk through that. You can get a team involved, and we can come out and do the full-blown engineering services. Maybe you've already decided what you need to do, and you can just basically, hey, give me a quote on this equipment. So we've also given on this part of the page a lot of tools here. So basically, we've got RF design tools, and we're going to kind of look at that a little bit more as we get into the wheres here. We've got the configuration software. We've got our full-blown training classes online. Webinars and net labs like we're doing here. This is something not only do you have to attend live, but it's something that we have up on the website as part of our video library. So you can go back and look at it, really dive into what you want to look at. And we've also got an extensive technical library from protocol specifics and everything else. So we kind of look at this, the how. It's really a three-step process that we're dealing with when we get into the how of doing this. We really want to look at it from first thing is we're going to do an RF network design. This is really a software feasibility study to make sure, can it do what we want it to do? We've got to look at, am I going to have enough signal, and how much data rate can I get out of that? If you're trying to do something like a video camera, we need to make sure we have enough data rate to support that. Once we're kind of get a basis in feasibility from that, then we move on to an actual RF site survey. And so this is actually a physical on-site analysis. We're going to come out and validate that software and make sure that the results are what we can expect. Okay. The other thing that this is going to allow us to do is we've got to find the right frequency for operation. Again, we're dealing primarily with the unlicensed frequencies. So certain areas, we're just going to have a lot of that channel pollution. We may have to go to a different frequency. Now, we also can help choose which of those channels do we need to use. We can also determine redundant or these alternate routes. Say we need a repeater. Now we can identify those when we're on site doing that site survey. Then the actual installation and commissioning. And so this is kind of the final step, and basically it's installed as per that site survey. We want to test the RF communications, make any changes. A lot of times these bigger projects can take some time. So what was an open channel when we did the site survey, maybe we need to move channels, things like that. That happens during the installation and commissioning, and ultimately then we go live. So as we kind of look at each of those, what we're going to walk through in that with this RF design, we've actually created this Excel-based tool here, this RF design tool, that allow you to plug in the numbers and actually see what the results are going to be. So when we look at that, basically you can see up here on that spreadsheet or that data sheet dashboard is that you can go in and select the frequency. We start looking at distance, and we start plugging in how much cable we may need, and then we can really look at what kind of results we're going to get. Now, some of what we're looking at is sometimes, some of us radio dorks, we like to look at, the RSSI, or how much signal in dB. Now, to the end customer, you guys maybe want to be looking at how much data rate can I get? How fast is it going to go? So we provide both of those. Then we also take into account what they call this Fresnel zone. And so that's also this ellipsoid pattern that you see down on the lower right that we've also got to be clear of when we're dealing with these high frequencies. So it's not enough just to get line of sight. We've also got to clear kind of this buffer zone. So this tool can actually do that. Once we're done with that analysis, you can actually compare it. So to give you an idea, if I'm looking at 2.4 gigahertz or 4.9 or 5.8 or 900 megahertz, I can compare my two options and see what's going to give me the best results for my application, right? For that, then we would, like I say, we move on to that site survey, and what we're actually going to do is come look at the actual location and investigate what other users are out there. So we bring a spectrum analyzer. We can look at it on a per channel basis and actually look at this in real time. So we want to look at not only on the left there, which is how much signal, but then also on the right side is kind of a heat map. So think of that as kind of duty cycle. How often are those channels being used? Once we go through this analysis, we can actually produce a report that would show you here's the same location, how much is being used at the 3 different frequencies. So you can actually go in and pick something like this. So in this case, something down in the 900 megahertz, we'd want to stick down on the lower side of that. 2.4, as you would expect, is pretty wide open, or is pretty busy. And the 5.8 gigahertz is pretty wide open. So not only does it show where, but you'll see down at the bottom, it actually shows you what channel to put the radios on when you're out there. It takes a lot of the guesswork out. You know, it's very hard to try and guess on what frequency other users are on. We've given you the tool to actually be able to go look and do that. So as you're modernizing, maybe moving into these unlicensed frequencies, you gotta make sure you're choosing the right one. So as we kind of wrap this up for at least this session, as I know we're getting close on time, you know, this journey of modernizing your wireless network, again, like I say, is we want to balance the what, blend it with the where, go through the how to really kind of drive us to an appropriate technology, right? So hopefully you'll be able to join us as we go through this modernization webinar series. You can kind of see the different sessions that are coming up. You go down into the handouts down there. We've also got this in a PDF format so you can do. It's available up on our website so you can sign up for the different sessions. This has been just kind of an overview to let you know what's coming so you can tune in maybe to the one that's a little bit more specific to you, what's going to make the most sense. And so hopefully you can join us next month where we're going to be specifically looking at modernizing for Ethernet networking. Something Joel's going to walk us through, and it's coming up on 4/13. Hopefully you can join us then, and we've got a couple minutes for any questions that you may have. If not, you can either give us a call, you can send it to my email, you can hit us up on the website. So again, thanks for joining, and have a great day.